I'm Neil Matatall. You can pronounce that however you feel like. I won't get upset. We're going to be talking about content security policy and how we manage it at GitHub. You can find me on GitHub at OreoShake or at NDM on Twitter. I am a product security engineer at GitHub, and what product security means to each company varies greatly, so I'm not really sure that helps. I'm also the co-founder of LocoMocoSec, which is a conference that would have had its third event 2 months ago, but has now been rescheduled and become online. Previously, I had worked at Twitter and UC Irvine and more, and I spent half of my life kind of doing development and half in security, so I think I have a little bit more of appreciation for these two sides of it. And I have two dogs named Dory and Crush, and yes, that is a naming scheme. So what is it? Content Security Policy, or CSP, is an HTTP response header or meta tag that manages some browser capabilities, primarily what JavaScript is allowed to execute. Once you have it in place, it has nice assurances that certain potentially bad things cannot happen by rule, but it can also limit your capabilities. This may or may not be a bad thing. And if you talk to anybody who has never implemented CSP or only partially implemented CSP or implemented it and moved on, they'll probably tell you that CSP is stupid, useless, and difficult. I only take issue with part of that. CSP is stupid difficult. It's very complicated. The spec has a lot of sharp edges. The implementations across browsers are not identical. So it's really tough to do. Let's just look at an example of a content security policy. This is an abbreviated version of GitHub's. It is a very, very long string. It is one of the longest headers on the internet that is not involved in setting cookies. It has gotten quite big over the years. It takes a lot of careful consideration, testing, experimenting, and planning. It is absolutely 1,000 times more difficult to retrofit than to build from day one. Most applications out of the box are 100% compatible with a very strict content security policy. It's only the stuff we add that makes it worse. The primary thing you're trying to avoid is having this value of unsafe inline or unsafe eval in your script source directive. The script source directive is the one that manages what JavaScript can run. This can include, for example, a host name, a host with a path, HTTPS to load any JavaScript from a SSL URL. But the directives of unsafe inline and unsafe eval control whether or not you can use the eval function in JavaScript, which is not inherently dangerous, but leaves open the possibility for dangerous things, or unsafe inline. This is, a script tag in the middle of your page with some JavaScript. The browser just renders whatever you tell it to. It has no idea whether you meant to have that inline JavaScript or not. But if you tell the browser, hey, don't ever run inline JavaScript, and it sees inline JavaScript, it knows not to run it. CSP often requires you to rework your application significantly. Lots of third-party, mostly visualization frameworks are notoriously not compatible with CSP, primarily because they make heavy use of the eval function, and they cling to that capability with lots of reasoning. You cannot simply remove all your inline JavaScript and get stuff to a CDN, but like the steps in between are pretty good too. So simply defining a policy is hard. Being able to coordinate a policy across many people is very hard. Think about a monolithic Rails application with hundreds of developers on it. Google recently did a research that found that a lot of the CSP on the internet provides little to no benefit at all. Again, it's a daunting task unless you've thought about it from day one. But a proper CSP provides many guarantees. Proper management of CSP makes the technology less daunting in general. And it kind of gets GitHub to a state where we're not like really concerned about XSS on our main application anymore. I don't say that in a cocky way, but I mean, if you can execute JavaScript that prints out a console message saying that your JavaScript was blocked, like, good job, but we're not going to stop what we're doing to handle that. So how you go about defining a policy? Generate a baseline policy. I suggest you do this manually. Install a browser extension that allows you to modify the header. You can start with the most restrictive policy possible and work your way backwards from that. The nice thing about CSP violations is the console will literally tell you what you need to add to your policy to make it work. You should do that with some caution because you want to be sure that the sources that you are adding are sources you intend to add, and you're not, for example, adding a superfish malware URL to your website's policy to enable the superfish spyware. That was a true thing. Superfish was in a lot of CSPs on the internet, including one I managed. Crawl your whole application. You know your application better than most people. Hopefully hit that one corner of the website that you don't even know that people know about. Make sure any feature flags are turned on for your users so you're not accidentally seeing old content or content that doesn't apply to you. But don't expect to get it right on the first try. Don't expect your first policy to be right. You're gonna get it wrong the first couple hundred times. The point is, start and move on. I think a lot of people, especially a lot of engineers hear this and they go, well, I'm just gonna hook up a crawler to generate my policy. And that probably, the time it takes you to write that reusable crawler is still probably gonna be longer and less fruitful than your manually crawling the website. There are tools, for example, the author of Caspr, as well as a product called Screen, do have products for managing a policy. It'll ingest reports, it'll make suggestions, and what you could do to the policy, and go from there. I think that those products are promising. I hope they can really, make it as simple as something that, for example, would have been designed by Apple, such that, everybody, people who maybe don't understand the backend frameworks, can even apply a CSP. This is, definitely a pie in the sky dream, but who knows? Now, I mentioned the reporting. The reporting is very valuable because your browser is not the same as every other browser on the internet. The way you use a website is not exactly the same as everyone else. CSP reporting will tell you every time a violation occurs. So it can be useful for both, tuning your policy, but it can also potentially detect an attack. Unfortunately, the level of noise in CSP reporting from when I last checked was way too high to ever potentially detect anything but like a massively wormable XSS bug, because all of the extensions on the internet generate CSP violations for your website, and you can determine whether or not it came from a plugin. You can look at, for example, the actual JavaScript that tried to execute will be included in some reports, but the reports themselves are not super valuable because of the amount of noise. And that's why I suggest you don't apply CSP reporting to every user who visits your site, but rather only the users that you have some reasonable assurance that they don't have 60 bad extensions on their browser. They hopefully don't have malware. For GitHub, this group would be our employees. Our employees use the website every day. So if something were to happen, they would be most likely to find it, and the chance that they're generating garbage is significantly lower than the rest of the entire internet. So again, CSP reporting can be useful for tuning a policy. I don't necessarily think it's useful beyond that. But the nice thing is, once your policy is in place, you don't really need the reporting because your policy is enforcing the rules. So it's doing its job. But you can't just turn it on tomorrow and break everyone's computer because you haven't tuned your policy well enough. There's a report only mode that will simulate as if you had applied the blocking on CSP, but instead will only generate reports and only generate messages in the console, but won't affect the way your application behaves. Again, if you have a group of people that you can reasonably rely on to test this safely and have some reasonable assurances that their browsers aren't garbage, you would put report only for everyone and then test it on your employees first. And if your employees can use it, then you eventually roll it out to the rest of the population. Definitely would suggest a very, very gradual rollout. If you could put this behind a feature flag and just do like 1%, 5%. People will tell you when things break, hopefully. Maybe your reporting is still in place and maybe that helps you find bugs. It absolutely has helped me find bugs that weren't security issues as well. It's kind of interesting in that way. So let's look at the capabilities of a content security policy. I'm only going to focus on the script source directive. There are many more directives, but they're less important to me. CSP allows you to define, for example, where you can load an image from, where you can make an XHR request to. And these are sort of, can be seen as exfiltration vectors, which they absolutely are. And I don't think CSP's job is to prevent exfiltration, is to prevent script execution that leads to exfiltration. So every time I see another article that says CSP bypass, and I see that they allow unsafe inline and unsafe eval, it's kind of, I don't like the word bypass in that context. An overly permissive policy leads to overly permissive protections. But let's look at an example here. I know we jumped straight into seeing a bunch of HTML and a header value, but I will try to explain this on the fly as we go. So the first value for script source is the word self in quotes. This means load a JavaScript file from the same origin as the current page. So that's pretty helpful. I mean, a lot of people, when you're just developing a simple application, everything goes to one server, and the static assets get handled separately. Local development, you typically aren't working with a separate domain, or self is pretty good for that use case. This also happens to enable JSON-P, so it's something you should probably want to get rid of if you don't need to support JSON-P. It also supports dynamic JavaScript. If you have an endpoint that spits back dynamic JavaScript on the same origin, this allows that sort of inherently unsafe behavior. Again, you can use it safely, or you could just not have the possibility of ever having a bug. I chose not having a bug. The second item here is the HTTPS with the colon. This says any HTTPS URL can be loaded. That's great that you've prevented, accidentally leaking the loading of a resource, but you've enabled the entire internet. Probably not a good thing. And we already talked about unsafe inline and unsafe eval, but we'll see examples of how they're used here. So the first line is not loaded because evil.com is not in my list of sources, and it's an HTTP URL. Unfortunately, our HackerMan does not have an SSL certificate. The second line there is a relative URL, so it is the same host. The third one is an SSL URL to a CDN, but because it's SSL, we allow it. Now, this image source on error, this is an example of inline JavaScript, because it is JavaScript that is essentially, taken as a string, and I don't know if it's under the scene eval, but it's kind of the same experience. This would generate an unsafe inline violation, but we've allowed this unsafe behavior. Similarly, the script tag below that allows inline JavaScript. We don't know if that's malicious or not. Now we've loaded this sweet animations.js file, which makes the use of the eval function to do something very interesting here. And lastly, it appends an inline script that says hello world at the very bottom. The only thing that wasn't allowed here was the loading of the evil.com non-SSL URL. Now, if we start to tighten down our policy, we've removed the eval function, unsafe eval, from our policy. Now, essentially, I've removed that first example. That'll always not be true with our policy. But the only difference now is I can't call it eval function. That alone is a huge step in the right direction. One thing that's definitely counterintuitive is the way jQuery did or does evaluate sort of a script tag as if you were to insert it into the DOM. It does insert it into the DOM, but it actually evals the content between the two script tags. So while it kind of seems like an inline script violation, it's actually an eval violation. Absolutely not obvious, but you've just closed a huge potential problem. So now we've dropped unsafe inline from our policy. This is a huge milestone here. That script source self, I don't like it. I don't like the HTTPS, but I've definitely helped the browser know what JavaScript they should not and should not execute, at least within the context of a loaded page. So our on error event handler will no longer run. That inline script tag will no longer run. And that document.body.append child will no longer run. So on this page, the only thing that was allowed to happen was I was able to load the JavaScript file from myself and from my CDN. Again, this is leaps and bounds better than nothing. Now, again, I didn't like the self. I don't like the JSON-P. I don't like the dynamic JavaScript. I just rather just move everything to my CDN. So by removing that self, I can no longer load that relative path. I will have had to move it to my own HTTPS CDN on an external server, but I want to specify my CDN. This is kind of your end goal for a CSP 1.0 policy. We'll talk about CSP 2 and 3 later and how they make applying CSP easier and less restrictive. But so all of this potentially dangerous behavior has now been disabled, and now the only risk is if someone goes and modifies my bundle.js file on my own CDN, which hopefully you have some control over and some access controls, and you have some sort of integrity checking, which is exactly why when you pair this with something like sub-resource integrity, you've really mitigated a lot of potential threats. You're saying only load it from this place and only load this content. This could be taken further, but this is what GitHub has today, and it's been quite nice for us. So I talked about the happy path, but nothing is ever that easy. Of course, removing inline JavaScript is not trivial. It might require you to completely re-architect the way you do things. The way things interact will be different. It's not rocket science, but it's also not something that can be automated fairly easy, I don't think. So CSP 2.0 introduces 2 features that allow you to leave your inline JavaScript. The first one is a nonce. This nonce will, as long as you have a header value, a nonce in the header that matches the nonce in the script tag, the browser will say, okay, this tag has been blessed. It is allowed to run. Now there's another feature with the SHAs that allow you to take the hash of the content, specify that in the header, and then you actually don't even have to modify your code at all. Your script tag as is, that value will execute. So you'll just have to take my word for it, but given the header above and given the HTML below, the first 2 will execute, but the third one will not because there is no hash or nonce present. Trusted types is a bit of a tangent here, but it is a part of CSP now. It's worth a whole presentation on its own. Essentially, it allows you to define how data is passed between interfaces with typed values in place of strings, because everything on the internet is parsing and generating strings. And when you're passing data around, it's nice to have some guarantees that a number, for example, is a number. And I just want to congratulate the folks at Google. This was a little, 2 months ago, and they deployed trusted types into a non-trivial application. And I really hope I get a chance to play with this sometime soon. It seems like a pretty powerful but definitely advanced feature of CSP. Another cool feature of CSP I want to talk about, this is a CSP 3 feature, is strict dynamic. It has been in Chrome for some time, and I also found out it's been in Firefox for some time too. I think it could definitely have an impact on the way people use CSP and apply it. This is sort of the third iteration of trying to make securing inline JavaScript better. Each iteration, for the first one that just had whether or not you had unsafe inline in your header, that's the most strict policy and more secure policy you can apply. Using nonces is not the best, but it can be very useful. Nonces still allow for inline JavaScript to be dynamic, which can lead to XSS. But even if it's not perfect, it's so much better. The hashes are kind of hard to use. A lot of people think, oh, well, I'll compute them on the fly. Well, then you shouldn't be doing that because that's essentially dynamic JavaScript as well. It's not necessarily a lessening, but it's just kind of hard. And then strict dynamic, again, makes it much easier to apply by only sacrificing a tiny, tiny bit of security. GitHub will not use nonces or strict dynamic unless we really can't find a way to work around it. But I should not say that you should not use this feature. I definitely encourage you to try it. Let's say this was your policy. This is going back to mostly what we had before. I have to allow unsafe inline, I have to allow unsafe eval and HTTPS, but I want to start applying these nonces. So essentially you supply strict dynamic with a nonce or a hash and unsafe inline and eval for backwards compatibility. New browsers know to ignore the unsafe inline, newer browsers know to accept the strict dynamic and discard the rest of the string so that it knows which resources to load. Sorry, that was very distracting. The problem with the policy above is it allows any HTTPS URL. An attacker can load any HTTPS resource, including out of data and vulnerable libraries. By adding a nonce attribute to script tags, fetching external resources, those resources will then be able to fetch other resources or add other JavaScript to the application. This sort of transfers the trust from one script to another without having to list out all the possible sources. So here we have HTTPS, maybe we want to list our CDN, maybe there's a marketing integration that requires us to add their CDN and then they want to load JavaScript, and then the JavaScript they load wants to load JavaScript, and you end up with this very long list of 15 hosts that you don't understand, that might be changing over time, that you might not control. But the strict dynamic feature allows you to sort of pass along this chain of trust so that the required libraries can execute the JavaScript they need, and they can load the JavaScript you need, and you don't have to constantly worry about updating your policy. Now, that doesn't sound inherently undangerous, it doesn't sound completely safe, but again, you've still eliminated the possibility of having inline JavaScript, which is really the big goal here. So going back to an actual example here, up in the policy, we have strict dynamic with our nonce. So the new browsers that understand strict dynamic will ignore the rest of what's behind it. So going back, our evil script cannot run. Our sweet animations can run because it has a nonce tag that matches the header. Same thing with our arbitrary CDN because it has the nonce. That inline script with the alert will run. The image source on error will not. Inline script tag without nonce will not. The eval function will not. But that script we loaded that adds some more inline JavaScript will run because we've implicitly trusted it to add more JavaScript. I found this website today, and I thought it really did a good job of explaining this whole process and how it is backwards compatible as well. CSP is not versioned, which makes things a lot more complicated. Knowing about the backwards compatibility is pretty important. It's become less important over time as the disparities between the browsers are different. And also that these CSP2, for example, has been around for many, many, many years. And the chance that you support a browser that does not support CSP2 is probably pretty low, unless you have wide variety of support. So it's less important now, but it was much more important going in the beginning and going forward that it'll have to be backwards compatible forever. And we can see all three levels in this policy. So content security policy, script source strict dynamic with a nonce, unsafe inline, HTTP, HTTPS. This feels like a very, very overly permissive policy. Feels like it's the kitchen sink, literally any URL, unsafe inline. But the presence of the nonce and the strict dynamic allows the browsers that understand them to ignore the unsafe behavior without breaking anybody's document. So the strict dynamic allows script which executes on a page to load more scripts via non-HTML parser inserted script elements. So specifically, this means you can't use a implicitly trusted JavaScript file to use document.write or a trusted inline script thing to use document.write to insert more script elements. You have to use like append element and things like that. So the second one has the nonce here, and this will be understood by CSP 2.0 browsers and above. You might get a warning in your console that it doesn't understand strict dynamic, but it is still enforcing that nonce behavior, which will then ignore the unsafe inline. And then we still have the HTTP, HTTPS. This is just because some browsers, we just can't break them. So this example again goes on to sort of show that if you could get your hands on a CSP1 browser or a 2 browser, you could show that this script works in every case. I kind of think it would be worth anyone interested visiting this page, look at the source of the color.js file, look at the way this thing works. It's not too clever, but it is kind of interesting. And I think it does do a pretty good job illustrating the functionality. But now I've talked about CSP enough about what it is, but now I've also explained sort of a strategy for applying CSP, but how does GitHub do it themselves? You can't just apply CSP as a HTTP response header in your server config file. It needs to live with the application. It needs to be dynamic. And it also needs to be managed in a way that's easy to understand. CSP is just a string. It is not rocket science. But having to splice and dice a string to make things, dynamic on the fly can, kind of be overly difficult and error prone as well. So provide an easy way for people to adjust the policies. And instead of asking someone, what should the CSP be on this given page, you ask, what is different about this page from our globally defined policy that requires an exception? By providing a familiar and documented API, developers can pattern match on this and copy and paste this safely in other places. And the security teams can then set up an alert to see if they ever see this function called to maybe give it a second set of eyes. This has definitely caught people from making changes that we may or may not be comfortable with. And having this familiar documented API enables both groups to really get the stuff done that needs to get done. Now that our policy is in enforcement mode, you literally cannot add a feature that is incompatible to the application without security knowing. It's a really powerful feature. And a real programmer, if you hear me, I'm sorry, I'm going to butcher this. I'm going to explain it in a way that is convenient for my story. Since everyone loves Rails, Rails is built using a version of the model view controller pattern. Speaking very liberally, the model is the data. In Rails, this usually represents a row in the database and its foreign key relations. The view is kind of what displays the data. This is where, for example, the HTML that is displayed to the user would be generated. And the controller is sort of what interacts with the HTTP request to then generate the model data and then gives it to the view to do what it needs to do to display all that data. And the only important thing here is you wouldn't really apply CSP logic in a model. You probably would have a reason for it, but we've yet to see it. When you have a view that's actually displaying the generated HTML, this can be a good place to modify your CSP. We'll show an example of that later. And primarily, I think the most common place where these things happen are at the controller level. If you're able to group functionality into controller behaviors, typically your CSP modifications are going to be similar across the actions of that controller, but they could also be completely arbitrary as well. So these are a few examples of actual GitHub code that's been changed slightly. We have this helper method in our base controller called add CSP exceptions, and that calls the method that would add generic CSP exceptions to a given page, thus, like, for example, adding a value onto your list of sources, as long as this controller defines this constant. If the constant doesn't define the controller, if the controller doesn't define the constant, it won't run. So in the second controller down below, we've defined the constant, says add foo.com to the list of URLs that I'm allowed to frame on a given page. That before action says, hey, call that method, but only do it on the show action. The show action is kind of like a Railsism for, like, if the index is a list of things, the show action is the page for that individual thing. But maybe this exception only applies to the show action, so we have no reason to, for example, either add it to our base policy or add it to other actions like the index. And then we also have this other controller down here that has a much more loosely defined things. It's nice that we can apply exceptions to controllers and actions, but sometimes we need the flexibility to say, I only want to add this third-party source on Thursdays in the year 2021, where the username starts with the letter L. It's a completely contrived example, but you do need that sort of flexibility. And that's not something Nginx is ever going to understand. It's also something I fear these third-party integrations will never understand either. And yes, you could probably build in things to, for example, maybe signal what features were enabled for a user, what their username was. But the flexibility of your own application can really just run whatever you want. And then I mentioned sometimes you just need to do things in the view. This underscore prefix file name above is a Railsism for what's called a partial. It's a reused piece of code that generates HTML. It can be rendered on any given page. So instead of the controller or the action having to know whether or not we're going to render this element, how about just, if you see this on the page, add it to the policy right away. And if you render the same thing 5 times, it's not going to add the same host 5 times. Has a little bit of smarts around that. And then just another example of why you can't trust Nginx configuration is if you're ever going to use the nonce feature of JavaScript, the nonce feature of the CSP tags, it's not impossible to add a random number to the header. It's not impossible to plop that value right into a script tag that you wrote. Or you could just write a helper called nonce JavaScript tag that does both for you, and you never have to even see the nonce. Little things like this make applying CSP just so much easier. And then there's also another use case. We have a baseline policy, but not all pages are the same. Yes, you're used to seeing the GitHub banner and the GitHub footer, and you generally have the same thing on most pages. But our error page uses a completely different CSP, and so we have this sort of separately defined policy that we can just use every time we need to. So at the bottom here, we have a helper method that says render 404. This can be called from just about anywhere in the code. Make sure we set the right CSP, and then we render the error page. We wouldn't want to, an error page is maybe not the best example of something you'd want to, ensure you really had the most concise and strict policy ever. But there are other cases where you're just going to need a whole different CSP, and you still want to build with that idea of start with the baseline, add the exceptions as you need them. This allows you to start with a different baseline. So that's all I have for today. I haven't modified a policy myself in years. I review a couple changes per week, and they're usually pretty simple. People at GitHub are well-versed at modifying their own policy, and by allowing them to discover the problems that our policy creates by adding new features and working with them during the review every time something like this triggers. I do think that there is a general knowledge amongst everyone at CSP, everyone at GitHub, with at least some familiarity with CSP and how to diagnose the problems you run into and how to fix them, or where to go when you can't figure it out. There absolutely have been times where people will come to me with a question about CSP, and some things are just not compatible, and it's not hard to know unless you've really investigated deeply. And that's pretty much the only thing I do with CSP nowadays, completely wholly managed by other people. So yeah, go out and apply a content security policy, y'all.
Sweet. Apply security policy. Make it everywhere, right? That's.
That was a great talk. So I guess one of the things, like Seth and I come across this quite a bit in courses, and it's like the question usually is, or not. It's not so much of a question. It's almost like we can't do CSP. Like our apps are too complicated, or we've got a structure that's not set up for it. And is that something that you hear a lot from folks? Do they come to you and ask that, or make that statement to you often? I mean, because this isn't the first time you've given some tidbits publicly on CSP, so I'm curious.
Yeah, I mean, there's literally things that are completely not compatible with CSP no matter what you do. I think I've seen people trying to work around some of these less common things, and the hoops they have to jump through are just impressive and are honestly beyond my understanding of how things work sometimes. But even on a very basic and simple page, it's just not trivial. And people will ask me, I get all kinds of questions all the time about how do I make this compatible? What do I need to add to my policy? And every situation is different.
Mm-hmm. So, like you talk a little bit about the things that are just not compatible with CSP. Do you have any examples of that, just off the top of your head, or is it a little bit too nuanced to get into?
It's funny because this just came up the other week. Someone definitely nerd sniped me into figuring out what sort of combination of hashing and would work to allow this bit of JavaScript to work. And the things it did, I mean, Ken, I know I sent this, you saw it. I don't know if you actually looked at it, but it did everything possible to not be compatible with CSP. And I got like 3 levels deep in different CSP fixes to get to like the 4th level and just be like, you know what, this is just not compatible. There's nothing that can be done. And it was only, the thing it was trying to do was trying to be, universal and load on every browser that's ever been written by using eval, by using all sorts of other like nasty inserting inline scripts. And it's just not necessary for modern browsers to do some of this stuff.
Yeah.
And another example is, marketing site wants to source third-party dynamic JavaScript, and they won't even let you review the unminified code. And you're like, well, so you want to just be able to insert whatever JavaScript you want, perhaps on a page that contains a user password, and you won't even let us like see the unminified code or like maybe support a static version of this page or JavaScript for some period of time before we're like forced to upgrade. And some say yes, some play ball, and some say like, no, we're not, like, and we say like, okay, well then we're not a customer.
Yeah.
And then some have just straight up like bent over backwards to like work with us and added, JavaScript APIs that we could use post message so we could frame their content on a site we own, source their JavaScript, but still be able to talk to our application in like a safe way. There's no way we would put their JavaScript on our pages.
What was one of my favorite things was, or is one of my favorite things is when folks have tried to include third-party source, and our static analysis tool catches up on them trying to modify the like secure header policy, and through like, for those that aren't familiar, it's static analysis is basically like linting for this constant variable to be like modified. Anyways, that's my favorite thing is like how that tool sort of tattled on people because we had CSP and you would have to make an exclusion for like a marketing widget, for instance. It sort of like tattled and said like, hey, probably not the right thing to do here. That's like probably my favorite thing to come out of our static analysis tool.
I
think you give it too much credit. Isn't a regular expression there?
Yeah. Well, okay. Isn't
that how all good static analysis tools start?
Exactly.
It's a regular expression engine.
Yeah. Yeah. No, but it's super cool. Like if you, if people wanted to do that in their own their own code base, they could have some global variable defined that has like a list of CSP policy statements and values, and then like if that's ever modified, then you get a notification on it. So, and actually that brings up another question, which is from David Corsi. Is there anything I can use with a very large number of apps to scan each one and give some kind of recommendations on CSP improvements?
I don't know about scaling it to a bunch of different apps, but there are services that will evaluate your CSP and provide suggestions. Obviously, they do it from the outsider's point of view of, yeah, just remove unsafe inline, no problem. But that's obviously the hard part. I am blanking on I think security headers IO was one of them. I think the Mozilla Observatory will also do it, but this is on like a one at a time basis. I imagine you could script it if they don't hate you for doing that. But I don't know of like a way to mass scan an entire enterprise.
All right. Let's see if we have any other questions.
Yeah, I mean, my question, like, again, being like a consultant on the outside looking in at most of the sites that I review nowadays, I don't see a lot of good CSP. I'm going to be honest, right? Like most, especially small to mid-sized companies, if they have any sort of CSP, it's a shock, right? I'll be honest. So like, where do you go from there? I know you always say, hey, it's easier to build from the ground up, but that's not always possible. Like, so what do you recommend? Just like broad swath, how do you get them to dip their toe in that, coming from the outside?
Well, I mean, obviously you got to start somewhere. Some CSP is better than no CSP. It's an iterative process for sure. There's some talk about like, well, do you focus on removing inline JavaScript or do you focus on getting a policy you can enforce?
Yeah.
And I would probably say it's more important to get a policy you can enforce as long as you're able to test it on reasonable people. You know, the policy when I came to GitHub was actually, the hard part was done. They didn't have any inline JavaScript. They hadn't been allowing it for some time. And it was just a matter of cleaning up the rest of the policy and adding more directives. And, you know, just because we had something on one page doesn't mean it needs to be part of the global policy. So once we had a static policy that was good and we started adding this sort of dynamic policy, but then using that as a way to tighten our policy while not making things worse going forward. You know, so generate a baseline, enforce it, add the dynamic capabilities to tighten it, but also going forward.
Okay, makes sense.
I mean, it came from a straight up use case. Like one of the first applications I applied CSP to had a WYSIWYG on one admin page, and it was allowing unsafe inline for the entire application. And it was like, that's okay, but we're like one step away from like making this application like 99% more resilient to XSS. And sometimes it's that easy.
Yep. Okay. I mean, yeah, that makes sense. I'm just thinking of it from a, you know, hey, I'm presenting a report or I'm like talking to the developers about CSP and where to start, right? Like, and so I think the advice of identify as much as you can where it's easy and then iterate from there is good advice in and of itself.
I would almost also say, don't even bother with the other directives first. Just do script source. You know, like I said, like I don't think CSP's job is to prevent exfiltration. Specifying where you make XHR calls to is great, and it's helpful, and it's self-documenting, but like that's not the threat I'm really worried about. And even if you do specify where you load images and XHR and whatever, you know, if a redirect occurs, there's nothing preventing that from exfiltrating data. There is a proposed directive, but it doesn't exist, and therefore there's no protection.
Yep. Okay, cool.
Oh, but also do object source none because that allows Flash. So script source and object source. I'm sorry.
Object source, script source, object source none. Cool. All right. Well, we'll tweet that out. Neil, this was awesome. You know, I know we're pushing up, I guess, against the time that we wanted somebody else. I'm saying that all wrong today. Sorry. It's been super interesting. You know, I know, you know, we were not necessarily on the camera the whole time, but I've been following all the stuff and just getting it outlined as far as what each of those different pieces do, and a test that shows that out with the code is very useful from my perspective, and I'm sure it will be across the board. So thanks again for coming on. Ken, anything else on the CSP front?
No, just appreciate you coming on and agreeing to do it. And we had to move the dates a bunch. Just, you know, with the pandemic, things happened and logistics, you know, I appreciate your flexibility on that and all of our speakers for that matter. So thanks, Neil. Appreciate that.
Yeah, appreciate it.
Thanks for putting together and thanks for having me.
Yep.
And I can't wait for Locomoco Sec when we can get back to it.
That is, so yeah.
More on that later, Seth.
Yeah, I'm sure.
All right.
Thanks, Neil.
Later.